In this section, we're going to take a look at interpreting chemical equations and the information that we can find in those equations. To do this, we'll take a look at the equation for the formation of ammonia, or nitrogen trihydrate. You can see from looking at this equation that 1N2 plus 3H2 will yield 2 ammonia. We can look at this chemical equation much like a recipe. A balanced equation tells you the relative amounts of the reactants and the products in a reaction. So much like looking at a recipe for cookies, the recipe will tell you exactly how many ingredients you need to make a certain amount of cookies. The same is true here. The equation is telling you exactly how much nitrogen and how much hydrogen you need to make a certain amount of ammonia. But we can actually look at this equation in a number of different ways. First of all, it indicates the number and the type of atoms that make up the reactants and the products. 2 nitrogen atoms and 6 hydrogen atoms will yield a compound that consists of 2 nitrogen atoms and 6 hydrogen atoms. This shows us that the equation is balanced, that the number of atoms on each side and the type of atoms on each side are the same. But the equation also indicates the number of molecules or compounds that make up the reactants and products. So we can say 1 molecule of N2 plus 3 molecules of H2 will yield 2 molecules of ammonia. But we can also look at this equation to indicate the number of moles of each substance that make up the reactants and products. Since a mole is simply a molecule multiplied by 6.02 times 10 to the 23rd, when we look at this equation, we can say 1 mole of nitrogen plus 3 moles of hydrogen will yield 2 moles of ammonia. This is actually a much more useful way for us to look at it, because very rarely do we ever deal with a single molecule of something, but we do look at larger quantities, or moles, of certain substances. To clarify, let's look at this concept a little bit more closely. On a small scale, the coefficients in the balanced equation indicate the number of molecules of each substance needed to make a certain number of molecules of product. I apologize if you can hear my dogs wrestling in the background. I couldn't get them to stop. Let's look at this in terms of the equation for water. 2 molecules of H2 gas plus 1 molecule of O2 gas will yield 2 molecules of water. But we can also look at the same equation in terms of moles. On a larger scale, the coefficients indicate the number of moles, indicate the number of moles of each substance needed to make a certain number of moles of product. Here's a picture of what you can hear going on in the background. A balanced chemical equation will also indicate the volume of each substance used or produced if all the substances are a gas. If we look at our equation for ammonia again, you'll notice all of the reactants and the product, the nitrogen, the hydrogen, and the ammonia, are gas. Since 1 mole of a gas at STP, no matter what kind of gas it is, always has the same volume, which is 22.4 liters, then we can look at these coefficients to determine the liters of gas used and the liters of gas produced. We will look a little closer at the idea of volume in a little bit. Let's recap all of the information that we can actually get from this balanced chemical equation for the formation of ammonia. N2 plus 3H2 yields 2 NH3. First of all, in terms of atoms, 2 nitrogen atoms plus 6 hydrogen atoms will yield 2 atoms of nitrogen and 6 atoms of hydrogen. This follows with the law of conservation of matter, or the law of conservation of mass, which states that matter or mass cannot be created or destroyed in the process of a chemical reaction. But we can also look at this information in terms of molecules. 1 molecule of N2 plus 3 molecules of H2 will yield 2 molecules of NH3. There's another typo. We could also use this information to multiply our recipe, so to speak. So let's say we wanted to make 10 times as much ammonia. Then we could say 10 molecules of N2 plus 30 molecules of H2 would yield 20 molecules of NH3. Again, that should be NH3. We can also look at the equation in terms of moles. 1 mole of N2 plus 3 moles of H2 will give us 2 moles of NH3. Sorry, I copied and pasted those sentences and made some adjustments, but the NH3, which should be there, got copied as NH2 multiple times. My apologies. And finally, we can look at this equation in terms of volume of a gas at STP. Again, this only applies if all of the substances are a gas and the conditions are at STP. Since 1 mole of gas at STP is equal to 22.4 liters, I've changed the information in the equation to reflect that. Instead of 1 mole of N2, we could say 22.4 liters of N2 plus 3 times 22.4 liters of H2 will yield 2 times 22.4 liters of the ammonia gas. Now, as you may have noticed, there were a couple of errors in that video. Since I'm not Miss Feldkamp, I will not be making you cookies. However, since you've finished your homework, feel free to go get yourself a cookie.